So now what we are doing is we are collecting the data. In the leftmost two digit that we can see the temperature is being varied by the hair dryer, and on the right we can see the drift. So when the temperature rises, we can see some different values of drift. These data will eventually give our model. So so if we plot drift versus temperature graph, we can actually fit a model which we actually created. And here you can see the temperature is constantly rising, and their corresponding drift are being recorded. So here it is a normal uncompensated digital clock. So if the FPGA always counts to 100 mega cycles, then its second is increased by 1, it is basically an uncompensated clock, because here whatever the temperature is, the clock always counts up to 100 mega cycles instead of counting up to the corrected count which we have in our lookup table. So it is basically an uncompensated digital clock. Here we cannot actually see any time difference. The time difference that we are seeing between the mobile screen and the FPGA is basically human error. The main issue is the drift is so less, so we cannot actually detect with our open eyes. So in this video we can actually see when the temperature rises, the clock counts faster and faster. So we are actually trying to see the effect of drift here. So the compensated logic is to match a temperature with its corrected count. So let's say when we have temperature 40 degrees Celsius, we have corrected count 50 less than the 100 megahertz original. But this is not actually, we cannot actually see or tell a difference between our original count, actual count, and FPGA count in our open eyes. So what we have done here, we have multiplied our drift by 10,000, and now we can see that the temperature is, when the temperature rises rapidly, the clock also counts more faster and faster. So it's basically, and give us an idea that in the long run, say for days and week, actually we can, the temperature effect will actually be there in the FPGA if we don't use a compensated clock.